So we talked yesterday about the binomial distribution, and remember I told you these first three things are the same for geometric and binomial. Okay? Each box or each trial is independent. So every time we choose the cereal box and we try to see if that toy's in there, the outcome of that one has no effect on the next box that we get. Okay? Each box either a success or failure. We got the toy we want or they didn't. The probability of success remains constant. Okay? Every single time there's a 10% chance. Just because we opened 8 boxes and didn't get it doesn't mean it's more likely the next time. It's still a 10% chance. Okay? And this last one, this is the condition that tells us it's geometric. Here we're looking for the number of trials until the first success. In the binomial, we were saying we're going to buy 7 boxes of cereal. How many of those have the toy we want? Now we're saying we're going to keep opening boxes until we get the toy we want. How many will it take? Okay. Once we have success, we stop with geometric. Okay. So when you're reading through a problem tomorrow, we're going to be looking at review where they're all mixed together. So I'm going to tell you which one. So that's how you're going to tell. If it says you're going to do this many and see how many successes, binomial. If it says you're going to do this until the first success, when you see first something, that's geometric. Okay. So here we're going to create a probability distribution for this geometric model. So we said P is 10%. So that means not getting the box is what percent? 0.9. Good. So, is it possible to have 0? Can we get a toy with not buying any boxes of cereal? No. Doesn't happen. So we can't start with 0. We have to start with 1. We have no chance of it happening until we buy a box of cereal. So, on the first box, what is the probability that we will get the toy we want? 10%. On the second box of cereal, that means first box, we didn't get what we want. The next box, we did. Okay, think of it like we did with the other probabilities. What happened this time? What happened this time? Multiply them together. Okay? So first box of cereal, second box of cereal. We didn't get it, then we did. The second box was our first success. So when we multiply these, it's 0.9. Okay, we go to 3. We didn't get the box of cereal we wanted. We didn't get the toy we wanted twice. So we have 0.9. Didn't get it twice, and then we did. Are you seeing how I'm getting this? So if I'm going for 4 boxes, 0.9 to what power? 3. And then 0.1. So 3 times I didn't get what I wanted, then the 4th time I did. Happening with our probabilities. They're getting smaller, right? So the probability of that being the first one kind of goes down a little bit each time. Now, I'm running out of room here at 7, but could I keep going? going and going and going. So that's one of the other differences between the binomial and geometric is this one doesn't have a set number of trials. It can have, we could keep opening, it may take us 25 boxes, we don't know. Hopefully it won't because that would be expensive. But it could. So you cannot list all the possible outcomes, but you can give enough of them to get the idea. Okay, so part A says, what is the probability it took 5 boxes to find the toy? There you go. It's just 0.066. What about B? The probability you found the toy in one of the first 3. So it could be the first one, it could be the second one, or it could be the third one. So we find each of those and add them together. It takes you more than 2 boxes. Yeah, because we cannot keep adding all these up because it could go on forever. So on this one, on geometric, you have to use the complement rule. So if it takes more than 2, that means we do 1 minus these. I hope that microphone. I hope so too. Okay, so what's the probability it takes fewer than 4 boxes? 1, 2, and 3. We already did that one up here. So we already know that one. So what about at most 2 boxes? Yeah. So this will just be probability of 1 plus probability of 2. We doing okay with that? Do we have questions? Okay, let's look inside. So, we would like to know a general rule. How can we write a general equation for this? So here, we're going to say P is the probability of success. Q is probability of failure. X is the number of trials until first success. Q to what power? 4, and then P multiplied with that. If we said it was the third one, Q would be to what power? Second, right? Because 2 times they didn't get it, the third time they did. So we're always doing Q and P multiplied. How do we get the exponent for Q? There you go. X minus 1. Because all but the last one, we didn't get what we want, and on the last one we did. So, as always, we like to know what is our rule for getting mean and standard deviation. So for mean, 1 over P. For standard deviation, we have Q over P squared, and then we take the square root of that. Now, these are not on the formula sheet. Sorry. The binomial is, but the geometric is not. So these are one of the few things you have to memorize. Okay? So I would recommend when you first get your test, write it at the top, and then you'll have it. So let's find our mean and standard deviation for the problem on the front. So we said P was 0.1 and Q was 0.9. So the mean would be 1 over 0.1 over 10. So we expect to buy 10 boxes of cereal to get 1 toy that we wanted. Kind of makes sense when it was 10%. Right? The standard deviation, we have 0.9 over 0.1 squared. So we see how the formulas work? So, let me warn you of this. When you're doing these, often these two may switch in the middle of the problem. Did you hear what I said? Sometimes these switch around. And what was a success is now failure, and what was failure is now success. Because it could be like on the brown-eyed, blue-eyed problem that you had on yesterday's problem set. It could be we were looking for blue-eye, and then we're looking for brown-eye. Okay, so what happens could switch. So you have to read carefully. Okay? So here, this is saying, suppose the probability is 25% that a given person will believe a rumor about the private life of a certain politician. So, I know no one ever says anything about politicians. So we have 25%. So this is, P is 0.25, and this is that people believe the lie, or believe the rumor. Okay? And then Q would be what? 0.75. This is do not believe. So this says, what is the probability the fifth person to hear the rumor will be the first to believe it? So that means the first 4 don't believe. So 0.75. And then the fifth one does. Does that make sense to you? Don't believe there are 4 of those. Believe 1. be that one of the first 4 people that hear the rumor will be the first to believe it. So it could be the first, could be the second, could be the third, or it could be the 4th. So we have to find each one and add them together. Doing okay? Okay, part C. What is the probability the third person is the first that does not believe? So now we have 4 people that do believe it, or 2 people that do believe it, and the third one doesn't. So see how these switched? So we have 2 people that believe the rumor, and the third one did not. So that's where you're having to be careful about reading the problem. You can't just go, third person is the first. I know how to do that. Read all of it. Persons. And standard deviation would be Q squared. And the square root of all that. Questions before you start on problem set? Okay. Problem set. Make sure you get this done for tomorrow. Exit tickets. Tell me the difference. I said this about 4 times, I think, at least today. What's the difference between binomial and geometric? How do you know which problem is which when you read through it? Is it a fixed number of trials, or you go until we get a success? Which is which?